First thing that I'm going to cover is more on the basics of cloud. What I've seen is people know about cloud, but they are not aware of the migration. The reason people are going for the migration to cloud. What is the current industry model, which is or the IT model, which is the virtualized data center. Okay, we'll talk about the virtualized data center. We'll talk about the reasons that people or the customers are moving to cloud, because say whenever we are doing this migration or design implementation, we always line up the business priorities or the reasons, business drivers that people allow users or maybe encourage people to move to cloud. So all those kind of things we will be talking about. Then some very basics on terms of these different IT models, which you see as a uh, water flow model in front of you. We started with on-premise systems, data center housing, data center as a service or managed services, then managed services in terms of virtualized data center, and then the cloud. So we'll be talking about all those things, and of course a few of the things like authentication factors and other things. Okay, so let me start with very basics. I'll be starting from here in the corner. If you would see this desktop and server, so just a difference between them. And the reason for that is because I want you to understand why servers are very special, or why for servers we actually need a special environment, which is actually called data centers. All right, so first talking about desktop and servers. So if you talk about a computing machine without any operating system, so that would something be called a computer, a machine that is actually able to do some computing. Okay, the moment you install an operating system on a bare metal of a computer, that particular machine either becomes a desktop or a server, depending on what sort of operating system you are putting it, right? So for example, if you go for a desktop OS like Win 7, Win 8 or Win 10, that particular machine becomes a desktop. If on the same machine, say it was still a configuration of 4 vCPU or 4 CPU, 4 cores with 8 GB RAM, still that machine, if you install the Wins server OS like Windows Server 2008, 2012, or maybe 2016. I'm only talking about Win Server, but you can have you can have Linux or even Mac too. So that same server becomes or same computing machine becomes a server. So main difference, first of all, lies in the operating system. The operating system actually decides if a particular computer would be more of a desktop or a server. All right. Second thing, if you talk about a desktop is generally used for 8 to 12 hours in a day usually, and then we are either in a tendency to shut it down or maybe hibernate it or put it to sleep. But a desktop is not running continuously, right? Also, if you talk about a desktop, this is more of a single purpose machine that is at a time only a single person can be using it. So if I'm sitting in front of a desktop or say a laptop, only I'll be able to use it. If you would have to use it, you would have to ask me to get off that laptop so that you can, or desktop so that you can use it. So a Windows or a desktop is always a single purpose machine. All right. Talking about server is more of a, first of all, it is used for 24 cross 7 cross n. N is the number of years till the time the server is in service. Okay, so it's for elongated service. So a 24 cross 7 machine, and then a multi-user. So you talk about a database server, a mail server, maybe a file server. On all these machines, you can see multiple users can connect at the same time. Let's talk about a web server. On a web server, maybe almost 20 people are connected at the same time, and or maybe if you're talking about a web server, maybe you can even see 10,000 of the people are connected to Instagram or maybe a Facebook web server at a time, and it really works well. So it is always a multi-user scenario. Now for such a machine, when you talk about a server, such a machine which is running 24 cross 7 cross n, it actually requires a special environment for a sustainability. Otherwise, the server might die just within 3 years. But if you would like to use it for an elongated time, you are looking for a better environment. And that's why data centers concept came in the picture, because data center is something which can provide a better, I would say, environment. Now, before starting with the data center model or anything, let's start with the IT models. How did the evolution took place? How did we started, and now currently we are at which model, and why everyone is moving to cloud, or what is the reason for people to move to cloud? I would still say not everyone has moved. Just around 20 to 25% of the overall customers have moved. Still, we have majority of the chunk on this model, virtualized data center. But still, let's talk about more about these models to understand, bit more. You must have seen or heard about this word managed services in your organization. Also, we'll talk about what is managed services in a holistic approach. So that would be some of the things. So let's start with on-premises system. So on-premises system, this was the first ID model, and this was the model in which till now the data centers were not involved. Nobody had heard about data center at that time. So what was the situation? People used to keep the servers in the same premise or the same office where the other employees were also sitting, right? Now this was something, of course, not good, because servers, we already talked about, need a special environment, and on-premises system was not having all of those. What are the special requirements and what are missing? Let's talk about that here on the top. So the first thing is the dust-free room. Now, if you keep your laptop or desktop untouched for say 2 days, you'll find a layer of 2 mm or maybe 5 mm layer of dust over the laptop. Now, dust, which we already know of, is something which can degrade the performance of your hardware, because what does dust do is it sticks with the hardware particle and causes the friction, while any sort of movement, and of course degrades the performance. In data centers, we do have wall endings. So it is like something like this. So say, this is the wall ending. The wall endings have these vacuums. Okay, these vacuums make sure all the dust is extracted. Okay, also during the routine maintenance, engineers are not allowed to go barefoot or with shoe. They have to cover their shoe, they have to cover their head, so that no sort of dust goes in. That sort of care we take care in the data center, but same was not available in the on-premises, right? Second, cooling system. Now, when you talk about servers or when you talk about the on-premises or offices, cooling is maintained through overhead AC vents, right? Wherever you're sitting, you see over the head, there is a AC vent. So that overhead AC vent is actually able to maintain a temperature of 16 to 25 degree of Celsius, which is actually optimum for human beings. So we generally prefer a temperature from around 22 to 25. Okay, even anything below 20 is not very comfortable, but at least something 16 to 25 is the range. Now, when you talk about the servers, they actually are looking for something like 6 to 16 degree, which is more optimum for most of the machines these days, right? Nowadays, we are also getting some hybrid machine which actually, get adopted towards the temperature. But again, if you talk about the overall, it is 6 to 16 degrees Celsius. Now, this is again something on premises you would not able to achieve, because you do not have special cooling towers over there. Data centers do have that, right? Third, talking about the physical security, in offices, you provide the physical security using the access card. That is, each and every employee have an access card through which they can punch in and punch out of their ODCs, or say whatever you call your offices, and then you can get into your premise. You can sit over there. Also for the server room, same criteria is being followed, that certain people on the access card have the access to the server room as well. Okay. Now, is this a very good thing? No. First, let's understand what are the maybe authentication factors, or what were the different option you might have. Okay, and then we'll talk about what is lacking on-prem and what is available in data center. So first, talking about the authentication factors, the first authentication factor is a knowledge factor, where you have knowledge of something, you remember something like a username and password is a knowledge factor. A ATM pin is a knowledge factor, because you know this, you have the knowledge of these two items, or you remember these things. Okay. Now, knowledge factor is not the most secure thing, because your credentials, your ATM pin, these things can be leaked, or these things can be maybe traced by someone. So we move to the second factor. Second factor is called the possession factor, where actually you possess some device, or you possess some kind of tokens on which you can receive a OTP, or some kind of token, or some kind of code. So for an example, mobile phone, mobile device is a possession factor. You possess a mobile device on which you can receive a OTP, a hard token, or even the access card is actually the second factor authentication, that is the possession factor. The access card is actually possessed by you. It is believed that access card would always be in your possession only. It would not be taken by someone else. That's why it is moved to the second factor. Now talking about the third factor of authentication, biological factor. Now, even with the access card, we have this concern that it might be shared by someone else. So for example, maybe Rahul and Satish or say Harry is my friend, and we all are working for the same organization. I'm having access to the server room. Now Harry and Rahul are also interested to see how the servers are stacked and how does the server room looks like, and they ask me if I can help them with my access card so that they can go in and see everything. So maybe if I'm not very much aligned towards the organization, I would hand over the access card to Rahul and Harry, and they would go into the server room, whereas they are not supposed to, but still they are able to go because possession factor is not such a easy thing. Or maybe I forgot my access card in the cafeteria, or maybe on my desk I went somewhere else, and that access card could be picked up by anyone, right? So access card is believed, the possession factor is believed not to be the most secure thing. That's why we talk about the third, which is the biological factor. Now biological factor is actually meaning, biometrics or biological traits like fingerprints, iris scan. It is believed that these two things cannot be stolen. Nobody would come and just cut out your thumb and take it away. This is not a movie, I would say. So biological factor is quite secure. Biological factor, but is a very costly technique. So if you talk about on premises, where you have maybe 1,000, even for offices like HCL and TCS in India, we have some campuses where we have 50 to 20,000 employees in a single campus. So for such organization, or even with large people, we cannot afford to go for biological factor implementation. That is employees getting in through the fingerprints. This is implemented at some places, especially data centers, because in data centers we do have only 15 to 25 or max 50 staff, where we can easily implement and manage the biological factor. But for a large audience, you cannot do that. That's why on premise you were not able to afford biological factor, but you were able to afford the possession factor that was through the access card, right? Then moving to the last factor, which is the location factor. Now this is used by a very coveted organization like raw, maybe, or some intelligence organization throughout the world, or say organization like some having a very classified information. Okay, so they would not let anyone with either the biological factor or any other factor to log in. For say accessing the vault, you might be only looking at a particular location to be available at, so that you can access some information. So that is called a location factor. Okay, so having said that about these authentication factors, now let's move back to the requirements, that what are the special requirements for servers and what you do not have right in the on-premises systems. So physical security, we saw that with on-premises system, you are going for an access card, which is more of a possession factor, and you do not have the security in terms of biological factor, which is actually, not affordable in the on-premises. You might be having a large office, say with 5,000 people, and maintaining the fingerprint database for 5,000 people and having that sort of hardware to, say validate that would be very costly if you have a large number of people to be done, right? Last is a dedicated power backup. So if you talk about the on-premises or offices, the power backup is actually shared by a lot of devices, printers, your desktops and laptops, tube lights, your coffee vending machine, and a lot of things. Same power backup is available with the servers as well. But if you talk about the data center, so data center does have a dedicated power backup only for the servers. The server rack have a separate power supply, and a separate power backup can be provided. So that sort of thing is again missing from on-premises system. All right. So due to all these factors, I would say we move to the second, or second model in the industry, and this model failed. The on-premises system, it was lacking of all these things, due to which we move to the second model in the industry, which is called data center housing. Now, this is the first time that data centers were introduced by some vendors or some businessmen, because businessmen understood this is the requirement which you do not have. So let's build out a facility and provide all these things. So first time data centers were introduced, but it was just called data center housing due to the fact. So I'll just highlight this word housing over here, because due to the fact that at that time the vendors did not have the competency to manage your servers. So what they said is, we have a data center facility where we provide you all these factors, but we do not have specialized team. I do not have a storage team or a network team or a server team who can manage your servers. What we can do is we can provide you this facility which you can use. You can come keep your servers in our facility and then have a proper environment for your servers. But I would not be able to manage and administration of your server would not be managed by me. That is still be done by you. And this is the reason this model was adopted by few people, but again many people were opposed to this, because I'm not looking for two vendors. I am not looking for a separate IT vendor and a separate data center vendor, right, as a startup especially. So the reason for the failure of this model is administration and management was customer managed. So since as a customer you would have to would have to manage the administration as well as the management of your service yourself. So this model was also actually failing or falling behind. As a result, we move to the third model in the industry, which is called data center as a service or managed services. Now, if you would have worked with organizations like IBM, Accenture, TCS, Wipro, you would have heard about this vertical called managed services. Okay, even nowadays we have this managed services vertical in many organizations. Now, what managed services or data centers as a service talks about? Now, same vendor now were able to equip themselves with some expertise teams. So now they were having different silos. So they were having storage team, backup team, Wintel team to provide the server build and maintenance, networking team, application development team, application testing team. So now not only they were providing you a data center housing, but also end-to-end management for all your IT needs. That is, they were having a development team for your application development and testing, servers team, and all sort of teams that you were previously looking for. So now this is only a single vendor that you have to deal with, and this actually is the reason for the evolution of IT in terms of infrastructure services. So when we say India is a hub of IT, the reason for that is the managed services, that many of companies in India provide these managed services. That is, they manage the end-to-end services for customer, and where this model actually build it for maybe the entire IT world, I would say. So data center service talk about that model in which now not only the data center housing is provided to you, but also the administration and management is also covered for you, where we talk about end-to-end management, that is application development, build, then server build and server maintenance, the networking, storage, everything that you would be needing as a IT service. So that was covered over here. The main thing, this was a complete physical model, and at that time virtualization was not evolved, or virtualization was not discovered till now. So this was a complete physical model. Now, due to the complete physical model, there were two challenges with this model that we had to move to the next. So first, let me talk about these two challenges, and then I'll take you through the rest of the things. So first is no scalability, and the second is server build time, which used to be more than maybe around 7 to 10 days. Okay, so these are two of the problems in this model, that is no scalability and server build time. So let me talk about both through an example. All right, so I'm taking example of, say, one of the managed services provider. Let's say let's say it is HCL. All right, so HCL have one of their data centers, let's say in Sweden, to manage the European customers. Okay, so let me just draw this data center for you, layout, and what all sort of services we are covering. All right, so let's say HCL have this facility where they have a 2000 square feet data center. Okay, the overall the overall limit or capacity of this data center is 100 servers. So you can have 100 servers. You have 4 racks over here. So I have aligned 4 racks, and each rack is capable of, let's say, holding 25 servers each. Okay, so 25 servers can be available over here. I have left space in between so that engineers can move and maintain the service. So impulse space, and then of course this is a well-stacked data center. Let's say HCL is providing the managed services and they invited different customers. So maybe now they have 8 to 9 clients or customers. Okay, and each customer is having somewhere around maybe 10 to 15 servers. Okay, so there was a time that when HCL started with a couple of customers, they grew to 8 to 9 customers, and now they have all the 100 data center, maybe 100 servers spaces filled. That is, all the customers now have 10 to 12 or maybe 15 servers, and the complete space that we were actually looking at for 100 servers is now full, and we do not have more space. Say two of the customers, which are of course European, let's say one of them is H&M. Okay, H&M we know have expanded their business in Asia and throughout the world, especially in India. We have a lot of H&M stores nowadays. So they came forward and they asked for actually, because they are expanding their business in other countries as well. They are looking for 5 more servers, 5 servers each. But now, since as a managed service provider, you have already reached the limit. That is, you were having a limit of 100 servers. You have already reached that limit, but your customer is looking for 10 servers more. So what HCL had to ask them that, sorry, we do not have the capacity in this data center, and maybe we are coming up with some new facility in a couple of months or 1 year down the line. Then we would be able to provide the services from their data center, but currently we do not have any capacity. Now, what is the option with this customer? Two things. Either first, stop their expansion plan, or second, they would have to look to migrate to other vendor. Now, moving to, or let's say not migrate, move to some other vendor. Moving to some other vendor was not an easy task. Reason for that, you would have to say do a lot of things. That is, say, uncable your servers from all the silos, then unbound the servers, then put them in a truck or maybe some transportation, transport the truck, all the equipment to some other maybe vendor. Okay, and that too is not an easy task if the vendor is offering it in a different country, in Europe only, but instead of Sweden they are offering the services in, say, Munich, Germany. Then you would have to wait for longer time. So outage of 8 to 10 days or maybe more can be expected, which every customer was not ready for, because mainly your services rely on IT, and IT would not be available for 15 days. That was a huge loss which everyone was not able to afford. So this was a very difficult situation for a customer, because this model is not scalable. That is, you reach out a limit where you cannot grow further from that. Okay, so first problem that we were talking about is no scalability. That solution itself was not scalable. Second was server build time. Now, let's say I'm the IT head of the organization, and one of my developers says, I'm looking for a server with 3 gigs of RAM. We had developed a new application for which we have been working from last 6 months. So that project is almost at the completion. So let's get a server with 3 gigs of RAM and a decent, say, CPU, and I'll roll out the application. Now I call the data center staff or the data center vendor, and I place this request that I'm looking for a server with 3 gigs of RAM. Now they might be having servers, the 100 servers that we are talking about, all are 4 gigs. So they say we have spare servers with 4 gigs of RAM or 2 gigs of RAM, but 3 gigs of RAM is something which you don't have. That would be more of a custom requirement. I would go and procure it from the market. Now I'm very stringent about my requirement. I said no, that's not an issue, but I need a server with 3 gigs of RAM only. So let's see what's the process now for getting this request fulfilled. So first step would be procurement, that the organization, the vendor would go into the market, procure the server for me. It would be transported into the data center, and then the second process will start. Second process talks about server mounting to racks. So server would be, now which it has already been transported, it would be mounted on the rack. Third, cabling to different silos. So you would have to cable that server to the network switches, to the storage, to the backup, to the power supply, all different silos. You would have to do a lot of cabling. So data center, you have seen a lot of cabling is done. So that sort of cabling would be done. And finally, server build and testing. before they can hand it over to you. Now, what do you think? How much days does it take? It sometimes even take more than 15 days because procurement itself is a huge activity. Now, I'm talking about emergency changes where they might be able to fulfill it within 7 to 10 days. Okay. Now, at that time, in fact, nowadays also, but software market was very competitive. You thought about a new feature. If anyone launches before you know your complete project or the effort spent in last 6 months might go to waste, or maybe go in vain. So that's the reason server build time, which was huge, was also not acceptable or was also causing issue, along with the no scalability. And the primary reason for that is this model, or this third model, the managed services, was a complete physical model. There was no virtualization yet. So as a result of these challenges, we move to the next model in the industry, which is virtualized data center. Now let's see what virtualized data center looks like. First, let me explain you server virtualization, and then we'll talk about more about this model. Okay. Now what I'm doing is, so we already have understood from this previous example that there are, say, 100 servers, all with, say, let me write it down. Let's say 4 gigs of RAM. Okay, so this is the current scenario. Now, what with virtualization or server virtualization took place is, so let me draw. So we took a physical host, a physical computer. Previously, what we were doing is, on that physical computer, we were installing the server OS on that, right? Now we are not doing that. We are not installing any server OS. In fact, what we are putting on that particular machine is called hypervisor. Now, hypervisor is a technique, or is a actually technology which actually do these server virtualize in such a optimized way that on a physical server, now you are able to create and run multiple virtual machines. Okay, so what I've done is, this is, say, a physical host, physical server, and these are the virtual machines that are running on the hypervisor. Now, what is the configuration? Let's say for the server, let's say I have taken 64 GB RAM. Now, what's the division? So these physical servers over here have been now converted to virtual servers. So, but they were still having the same configuration, that is 4 GB RAM. So if I'm having 10 virtual machines over this, so 1, 2, 3, 4 till 10. So first of all, 40 GB of RAM, 40 GB of RAM. This is meant for the virtual machines, VMs. 4 GB RAM is also required for this physical server, because it has to manage these virtual machines. It does not do any other work, but for the physical, for the VMs management, it does require some RAM for itself. And then 20 GB of RAM. This is the buffer. I'll let you know the reason for putting up such a good buffer. Okay, so now we total have 100 servers. So we would have at least 10 into 10 of such solution, that you would have more physical hosts on which you are having running physical VMs, these similar VMs, right? So physical host, virtual machines. Now let's say one of these physical hosts goes down. So what would happen? All these 10 virtual machines along with this physical host would also go down, and that would even lead to a much bad situation. Previously, I was also talking about only the crash of a couple of servers. Now 10 virtual servers are crashing altogether. So this is a bad situation. But hypervisor vendors like VMware, Microsoft, they take care of this crash through something called automatic migration. That is, automatically your machines get migrated to other physical host. Okay, and then they use the compute power from that host. But this is only possible if you have this buffer. If you are already running with a tight capacity, that is, you need 44 GB RAM and you're running with only 45 gigs of RAM, or maybe 46 GB of RAM, you would not be able to accommodate any virtual machine which is coming from other hosts. That is the reason I have kept this buffer as a good design. So this was the solution overall. So you see, the virtual machines are created on a physical host, and there is no limit for this. Today I have went for 64 GB of RAM and got 10 virtual machine. Tomorrow I would have gone for, say, 640 GB of RAM, and I could have maybe more than 120 virtual machine on the same physical host. So there is no limit on scalability now. So previous issue for no scalability now is addressed through the unlimited scalability. Even in the same data center with 100 physical hosts, you can have up to 100,000 servers. That is 1 lakh servers, and that is also possible because nowadays VMware allows you to have 6 TB of RAM on a physical host, which means maybe you can have more than 1,000 virtual machines running on this virtual machine, this physical host with maybe 4 gigs of RAM each virtual machine. So that sort of things are possible. Second issue, server build time. Now, server build time is just hours, or maybe it just take you 2 hours. Why? Because now you have extra buffer. You just have to right click on the hypervisor, select new virtual machine, give all the specification that you're looking for, say 3 gigs of RAM, this much CPU, this operating system, then just execute that. Or better than that, nowadays we have the pre-built templates. I have a template for Windows Server 2016. That's what you're looking for. Just within maybe 1 hour, I'll be able to deploy. So all these steps that we previously saw, you do not need any procurement now. You do not need any, say racking or mounting now. You do not need any cabling now. Everything is in place. Only you need to do is server built-in testing. That too is created through templates because this is a virtual environment. And the server build time, which previously was 7 to 10 days, is now coming down to just few hours. Maybe nowadays people are delivering the service within 4 hours of the delivery. So that's how virtualization has changed entire thing. Server density, and in fact the data center density, where per data center previously you were only having 100 servers, you can have now thousands of servers, and that gave these managed services vendor a much greater power to be handling a large number of customers. Previously they were able to manage only 8 to 9 customers. I think now they can even manage up to maybe 50 to 100 customers because they have got a very large density of servers per data center. This is the power virtualization provided, and that's the reason virtualized this data center is the current industry model, and up to maybe around, just let me read, right, 65% of the customers are still working on the virtualized data center. People are using VMware, people are using Microsoft Hyper-V, Citrix Hypervisor. So these are some of the products people are using. About 25% people have migrated to cloud, and around 10% of the people are still stuck on one of the above models, right? So this is the overall scenario. Let me delete some of the stuff so that we can now discuss about cloud. Now you might be wondering if throughout this journey we have talked about the lackings in these models. Say I was talking about lacking in data center housing, lacking in data center as a service. So next I should be talking about the lackings in virtualized data center, right? Then only we might have decided to move to cloud. So actually, to be honest, there are no technical lackings or technical challenges with the virtualized data center. It's a very good model. It's a great efficient model. The only thing is the human requirements that have changed in such a way that we had to move to cloud. So it is not the technical challenges but the human requirements. Now let's talk about these requirements. So the first thing that I can think of is self-service. So nowadays people have started looking for self-service. Okay. Subramaniam, I'll be covering Azure versus cloud, that is Azure versus AWS versus GCP once I cover this. So just wait for a few minutes. So first requirement that is coming from the virtualized data center is the self-service. Nowadays, what people are asking is that we want to build our server ourselves. The reason for that, let me give you on the same example that I am the same IT head of the company, and previously the data center vendor was charging me $100 per server build. Okay, now they have moved to a virtualized data center model, something which I've heard from them. I do not know about this model. Now also the charges are almost the same, but they're able to deliver the server just within few hours, which previously they took around 10 days to deliver. So I was very curious. I tried to Google it, and I found this. The server build activity is quite simple. You just have to right click on a software, select a new virtual machine, give the specs, and you are done. You are good to go. Why to give $100 for such an activity which can be managed by one of my developer, or even me as a person, or maybe some other people whom I can get to build 100 virtual machine and just pay them a salary of maybe around 10 virtual machine. Why should I pay this vendor? So people have started the requesting for self-service, because server build nowadays, a virtual machine, creating a virtual machine is not a difficult task. And the reason people now work looking for, say, self-service. Now, when you talk about the virtualized data center model, in this model, giving self-service is not such an easy task. So let's say this is a shared model on which the customer have 3 virtual machines running on the physical host. If the vendor gives you self-service, that is the access to the hypervisor to create your virtual machine, you might also be able to access the virtual machine for other customers, which would be a contractual breach, because it has to be a complete isolation. Nobody else should be having access to the servers which were already given in the contract. So that's the reason that data center vendor would not be able to give you access on the hypervisor to manage your machine or create your virtual machine. So the self-service which you are requesting in a virtualized data center is actually not possible. As an organization, you cannot give everyone access to the self-service module, right? Like we see in Azure, we have a management portal, and that management portal allows anyone to create virtual machine. Same was not available with the or is not available with the virtualized data center, right? Second thing, second requirement which is coming nowadays is PG or utility based billing. Let's talk about this. What is PG or utility based billing? Now, PG stands for pay as you go. So what is the current billing model for IT industry is 24/7. So if a managed services provider is managing your service for you, they're charging you 24/7. As a IT organization or as a maybe financial BFSI customer, I might be saying that I'm a financial company or a banking customer, and my employees are working from 9 to 5. That is for 8 hours in a day, and that to Monday to Friday. I'm not working Saturday, Sundays. Okay, so what I'm looking for, what my consumption is, it is 8/5. Okay, what I can do at max, that I'm starting at 9, closing at 5. So what you can do is power on my servers at 8 a.m. and shut them down at 6 p.m. I'm pretty much sure no one will be using them. So I can pay you 10/5, but not 24/7. Now, what is the thing that data center vendor has to say over here? Now, in a managed services or a shared model, he would say, even if, say, I shut down all these 3 virtual machines of yours, first, second, and the third one, right? I still have other virtual machines running on this physical host. So this physical host will still be running. It would be consuming electricity. It would be consuming the cooling through the cooling tower. During the night shift, I would have to call my staff and pay them extra. So I myself is incurring a 24/7 cost. And that's the reason that I'm charging you 24/7. So currently the people who are asking for a pay as you go model, that or the utility based, what is a utility? Like electricity, a water. So electricity and water, you only get the bill as per your consumption, right? Similar thing you can expect or you get in the or you are getting as a request from the customer, that only charge for what we are using. So even IT as a utility. So that thing is being asked nowadays, which is also a bit of challenge and not possible through the virtualized data center, right? Third, auto scaling and auto shrinking. Now, auto scaling and auto shrinking is another requirement that is coming hot these days, especially around the server utilization. So let's talk about first example. I have 2 examples to cover here. So let's talk about first the e-commerce industry. Let's say Flipkart and Amazon. So these 2 companies are going for a lot of big billion day sales, winter sales, summer sale, where a enhanced traffic or increased traffic is seen on the website. Let's say Flipkart is having a total server capacity of 100, and with that server capacity, they are able to address a total traffic of 6 million users per day. Okay, if everyone is working concurrently at that point of time. Now, Flipkart is actually looking for a big billions day sale. Average traffic nowadays is 3 million on their website. They know that they can handle 6 million. They expected that during the Big Billion Day sale, the traffic would be somewhere around 5 to 6, maybe 5.5, not more than 6 anyways. But somehow the traffic actually was seen as a 7 million traffic, where the server capacity was only for 6 million. So that due to that 1 million extra traffic, the server was actually getting freeze or crash. And then this we have seen with the in these sales that the cart is not working for say 1 hour, or you were getting some outages. So this was seen, and this actually causes a huge reputation loss for these kind of organization. So what they are looking for is auto scaling and auto shrinking, where without any admin intervention or without any admin creating of servers, automatically your server count grows from 100 to 110 or 120. And when the traffic is very less, automatically server count comes down to 100 or even below that. So that is auto scaling and auto shrinking technology. And this is not only with e-commerce, but even with some other organization. Let me talk about the second example. I'm giving an example of food delivery agents or companies, like let's say Zomato and Swiggy. So these two are, let's say, Uber Eats. So what these organizations are doing is they have this model to deliver the food. Now what they saw is Monday to Friday people have good tendency to order, but on Saturday Sunday they have more. So maybe let's talk about Zomato. So they saw a traffic of maybe an order of total orders of 1 lakh per day, Monday to Friday. But when they talk about weekends, that is Saturday and Sunday, the capacity or the order inflow orders are 1.5 lakh, right? Due to this, they see that for 1 lakh orders they need 10 servers, but for 1.5 they need 15 servers. They have two options: either go for 15 servers throughout the week. I know from Monday to Friday, 15 servers out of 15, 5 would not be used much or would be a wastage. Or Monday to Friday, have 10 servers. Saturday, Sunday, have somebody, deploy 5 servers on Sunday midnight, have those 5 servers decommission back. Again, costly. So these organizations are also looking for something called auto scaling and auto shrinking, where automatically on Saturday morning, let's say 8 a.m., server count increases by 5, and on Sunday midnight, the server counts come back to the 10. So that is the auto scaling and auto shrinking these people are also looking for. So the auto scaling and auto shrinking, which is coming as a requirement, is now used or maybe required by almost many organizations around the world, right? Which is also not possible with the virtualized data center due to the limitation. Maybe people can do it with some orchestration engine, but not in that efficient way which cloud offers you, right? And then let's talk about the last offering, or not last, I would still say project turnover, or let's say quick turnover. So I've done a lot of virtualization product and work projects, and what I've seen is, say customers looking to move to virtualization, say implement Citrix. They might not have the appropriate hardware, and when the projects come to us, we do the assessment. We tell them that you would have to. This is these. We provide them a build prerequisites document. That these are the prerequisites which you have to meet before we start with the build activities or after the design phase, right? So this always follow the design phase. Now, let's say the customer does not have the appropriate hardware at that one of time, and we ask them to get the hardware procured. It might take around 1.5 months for the complete thing to be done, and then we start with the build. So what we are able to do, we are not able to provide them a quick project turnover. They are looking for the project to be done within 1 month, but it took around 3 months. Why? Because with let's say virtualized data center, still it depends on physical host, physical servers, which for the procurement or the overall readiness might take time. Whereas when you talk about cloud, there is no such requirement. On day one, you can directly go and create your virtual machine and get ready. So the project which might have taken 3 months would be able to be delivered within just a month with the cloud. And this is a practical live experience that I'm talking about, right? This we have done with a lot of customers who were having limited budget, who were having say approval limits, and they were not able to go to the go with the self data center, and they had to choose the public cloud, and they were happy with the results later. Okay, so this is what cloud has to offer you, and that's the reason that. And there might be more reasons, to be honest. These might not be only the 4 reasons which I'm talking about. There might be more reasons, but these are some of the primary reasons that we are moving from virtualized data center to cloud. All right. Now, just a quick overview, revision, and then I'll talk about the cloud model. So we started with the on-premises system, where we had limited facilities for keeping our servers optimally. Next, we moved to the data center housing, where first time we came with this concept of data centers, and we actually have the data center housing. But Administration and management was still customer managed. As a result, we moved to the next model in the industry, which was called data center as a service or managed services. Now, managed services or data center as a service model talks about the model in which, apart from the data center housing, you're also getting the managed services or the different teams to manage your different IT needs. But this was a complete physical model. As a result, we moved to the next model, which is the virtualized data center, where virtualization was I would say evolved or discovered for the first time. And virtualized data center is the current industry model, where approximately 65% of the customers are working. We saw few of the requirements from us changing in such a way that now we have to move to cloud. And cloud is something which have seen around 20-25% of the customer throughout this world. Very, very big companies like Netflix, they have completely migrated to cloud. Netflix that does not have any of their footprint, I would say physical footprint now. They do not have any physical data center. They're all into cloud now. And there are many such organizations which I can tell you about. So cloud is one of the most adopted model nowadays after the virtualized data center. Okay. Now let's talk about cloud. How does it look like? How does it resolve most of your problem? And then we'll move towards the second break, right? So first talking about the cloud model. So the basis of cloud is also the virtualized data center only. Sorry. Right. So let me draw here. So these boxes which I'm drawing are all virtualized data center. Okay. So when I say these, so this is the virtualized data center, virtualized data centers. Okay. On top of this, there is a layer of what we call a layer of fabric. And on the top here, we have the management portal. Okay. So as a user, as an organization, as a customer, what cloud vendor provides you is access to management portal for all users. So as a user, you get the access to the management portal through which you can view and create any service, any resource that you want. All right. So say as a user, you have the access to create virtual machine. If you want to create a virtual machine over here, you can do that. Now, through this management portal, you have access to maybe almost 100 data centers in the world. So Microsoft has more than 100 data centers to give you Azure services, and these data centers are spread across the world. There are more than 40 regions across the world where you can see Microsoft data center. Say this is in Japan, this is in India, this is Australia, this is US West, right? This is Germany. So let's say the user wanted to create the data center or their virtual machine, let's say in Germany. So he would be able to do that easily. Now, in a way, user has access to Germany data center, but he cannot see the resources of other customers. This is an isolated environment. What he can do is he can only see the resources that he created through the management portal. And also the access that we are talking about, okay, that user is able to create the virtual machine in the data center. He's actually talking to the, when he's creating a virtual machine in the portal, he's actually talking on the to the APIs on the fabric layer. The request goes to these APIs, and in return these APIs actually create the particular resource in the particular data center. So as a overview, if you would see, cloud is able to provide the self-service. They have the management portal where you can create any service that you want. They're able to provide you pay or utility-based billing. So for a server with 4 gigs of RAM, not even that, let me talk about 4 VCP and 8 gigs of RAM. You just have to pay, I created just another day, you just have to pay 4 rupees per hour. And that's a very, very minimum cost. Nowadays, even Cyber Cafe is asking you 20 rupees per hour for a computer usage. They are just charging you, Microsoft is just charging you 4 rupees per hour. If you use that server only for 10 hours and then shut it down, they would only charge you 40 rupees per day for that particular day. And in a month, if you have used it for 22 days for your working days, you just have to pay for 880 rupees per month. So that sort of cost saving you can expect. Then they provide you auto scaling and auto shrinking in terms of two things. The auto scaling and auto shrinking can be provided on the basis of metrics, or say the matrices, where you can use CPU. Like if CPU reaches 90% on all my servers, increase my server count by 10, okay, or 5. So either it can be done on the basis of CPU, memory, or say HTTP queue length, something like that. All right. Or you can do on the basis of schedule. Say on Saturday morning, increase my server count by 5, and on Sunday midnight, decrease it by 5. So that sort of thing can be done. And then quick project turnover. So that can Azure can provide, or any cloud service in that perspective can provide a very quick project turnover, because you do not have to worry about the hardware cost or the readiness. In cloud, you are ready on the first day. So you just have to create a virtual machine, get the overall infrastructure configured, and you are good to go. You do not have to wait for the readiness from the terms of data center side or the physical server side. So that's something. And again, one more very important point that I can talk about is virtualized data center. They offer you only three services, that is a virtual machine, a virtual network, and a virtual storage to be created. When you talk about cloud, it is not only these three services. These are only the basic three services. Apart from that, cloud also offers you, say the services like databases, web apps, big data, any other services pre-built. That is, you do not have to configure it. Like even talk about Kubernetes, the complete Kubernetes cluster is deployed already. You just have to go and deploy your website. That's it. Otherwise, if you would have done that in the virtualized data center, first you would have to build the complete Kubernetes cluster. Maybe you would have spent around 3 to 5 days in that, and then maybe you would be starting with the creation of the website. So all these services, along with virtual machine, virtual network, and virtual storage, are also covered in cloud, which you do not see in the virtualized data center. All right. So that's all about this complete cloud journey. So let me know if you have any questions, and then I'll be talking about the differences between AWS, Azure, and GCP. What should be a choice? So already selected the Azure, but then why it is a better choice as compared to AWS and GCP? And I'll talk about those differences. So